Hi, everybody. Welcome to Science. Today is October the 25th, and we're looking at our last topic of chemistry, which is neutralization. Before we begin, what do you think happens when we mix an acid and a base? Record your ideas below. All right, a little review here. Acids produce hydrogen ions when they dissolve in water. They have a sour taste and turn litmus paper red. The pH levels are less than 7. Bases produce hydroxide ions, which are OH negative, when they are dissolved in water. They have a bitter taste and turn red litmus paper blue. Their pH levels are greater than 7. The pH scale measures the acidity or alkalinity of a solution. I like that word better than basicity. The scale ranges from 1 to 14. A substance is neutral if it has a pH of 7. An acidic substance has a pH of less than 7, and a basic substance has a pH greater than 7. We use pH paper or an indicator to find the pH of an aqueous solution. To test whether a solution are acidic, basic, or neutral, you simply drop a small amount of the solution onto a piece of the paper and then look at the color. I think back to the gizmo we did when we started introducing pH and how we took that little piece of paper and dipped it into the different aqueous or water-based solutions. I'd like you to pause this video right now and look at the description, and there'll be a link to Mr. Rohweder's video. So go ahead and pause this video, watch the other video, and then rejoin us. All right, so after the video, you should find out that acids again release hydrogen ions into solution and bases release hydroxide. If we were to mix an acid and a base together, the hydrogen ion combines with the hydroxide ion to make the molecule water. A neutralization is a reaction with an acid and a base, and it produces water and salt. That sounds like a test question. The reactants of a neutralization reaction are acid and base, and the products are water and salt. Here we're really thinking about what's happening. So here in this example, we're taking HCl, which is hydrochloric acid, and sodium hydroxide, and we're thinking about how the things dissociate here in stage number 2. So these things disassociate into the different ion components here. And then this H combines with the OH to form our water, and then the Na and the Cl get together to form this salt. So I like that we're kind of thinking about in the first part up here what happens, and then the explanation down below. For this one, I would like you to pause the video and try and complete this on your own. And then also read through this, looking at solute and solvents and some images. So again, pause this. The kids in class are going to take about 15 minutes to work on this. So please, again, pause this video, and then we'll see how you did compared to what the answers are. All right, so for this one, if you look at the upper part, this is the acid, and it disassociates into the hydrogen and the bromine and the K and the OH. The hydrogen and the hydroxide combine to form water, and then this forms a salt, KBr. HBr and KOH are combined together. HBr is the acid and KOH is the base. Since HBr is an acid, it releases hydrogen in solution. Bromine is the other ion that HBr disassociates or breaks into. Since KOH is a base, it releases hydroxide, ions in solution. K is the other ion. KOH disassociates or breaks into. H and OH combine, and Br and K combine. H and OH form H2O. K and Br form KBr. H2O is water, and KBr is our salt. Therefore, the acid and base combine to form salt and water. Here we're looking at solute versus solvent. The solvent is what things are dissolved in. So in this case, it's water, the liquid, and then the solute is what is being dissolved. So here we're supposed to label this and then underline where you got the information from. Here, I'm going to have to pause this video and do a part 2. We've got lemonade, Kool-Aid, salt as things I've seen. Something dissolves in water. Salt is the solute, water is the solvent. I drew a picture of what that looks like.